What do you call a singing cow? Obviously, a musician. Welcome to another video. We are talking today about identifying solutions to simultaneous linear equations. Okay, so this one here, if I'm honest, is probably going to be a very easy, straightforward one. It may require a little bit of work. However, identifying solutions is probably the easy one. Finding them yourself, that's going to be the next lesson. That might be a bit trickier, but identifying solutions, definitely a little bit more straightforward. So a couple of things to touch on. Please remember when I say the word simultaneous, just remember that the actual meaning of the word, if something happens simultaneously, it kind of means at the same time. Okay. So if I am cooking and cleaning at the same time, I would say I'm simultaneously cooking and cleaning. Okay, it just means at the same time. Now, what does this look like mathematically? Um, what it means is it's kind of one coordinate, one common coordinate on two different lines. Okay, so essentially what that means is you'll notice that there's a coordinate that's the same on both different lines. Um, that means that there's a value for x and y. So that means there's a x value and a y value because it's a coordinate. And graphically, this is the most important part here. It's what we know as the point of intersection. Okay, I just took a long time to say that a solution for your simultaneous linear equations is you'll have two lines, and the point that they meet, that exact point is actually your solution. Okay, so all you have to do is identify it, tell me what the x value is, the y value is. That's your answer. Okay, now there's a couple things that you'll need to do. So you can identify a simultaneous solution from a table of values. So if we're doing a table of values, you'll fill out the table of values first. So we've kind of got the x values kind of done for you, but now you just fill in the y values, and it says it's x minus 2. So this one would be minus 4, minus 2, 0, 2, 4. And for this one here, it's minus 2x plus 4. So if I'm not mistaken, this should be 8. This should be 4. I hope I'm doing this right. This should be 0. This should be minus 4. This should be minus 8. Yeah, okay. So hopefully you remember how to fill in your table of values. Now I'm hoping that as you fill this out, you can see, oh, what's going on here? These are two different equations. These are two different table of values, but they have the same points. And so for this one here, you'd say that the solution would be x equals to 2, y equals to 0. That is your solution. Or you can write it as a coordinate, which is always x and then y. So 2, 0. Hopefully that makes some sort of sense. Okay, so that's how you do it from a table of values. Now, another thing that you'll often be asked to do is you'll be often asked to check if an answer is a simultaneous solution to your two equations. Now, with checking, it's a little bit easier. You don't have to do a lot of work. You just have to substitute, okay, the solution into both equations. Now, with the solution, remember that there's an x value and a y value, so you have to substitute in both. Okay, so the example would be, is 3, 6 a simultaneous solution for y equals x plus 3 and 3x plus 2y equals to 21? Let's check. So I'm going to talk about y equals to x plus 3 on this side, and I'm going to talk about 3x plus 2y equals to 21 on this side, because I need to check both. It must work for both. Sometimes it'll work for one and it won't work for the other. It is not a solution. Sometimes it'll work for none of them. Definitely not a solution. But if it works for both, it is a solution. Now remember, a coordinate is always x and then y. So in other words, it's saying that, and I'll write this over here, it's saying that x equals to 3 and y equals to 6. So what does substitute mean? You're going to swap things out. So as I substitute, y is the same thing as 6. X is the same thing as 3. And then that plus 3 is just plus 3. let's just evaluate that. Is 6 equals to 6? Yes, it does. So that's all good. So far, it's looking like it could be a solution. I just need to check that it works for the right hand or for the other equation that we're doing here. Okay, now for this one here, 3x is not going to be 33. It's going to be 3 times 3. And it's going to be 2 times 6. And it should equal to 21. Let's quickly do the math here. 3 times 3 is 9. 2 times 6 is 12. And 9 plus 12 is 21. And oh, would you look at that? They both equal, or they both are true. I know 6 is not the same as 21, but you've got the left-hand side equaling the right-hand side for this one. And same here, your left-hand side equals the right-hand side for this one. They are both true. Therefore, 3, 6 is a solution. Okay. Hopefully that makes some sort of sense to you. And I think that could be identifying simultaneous from a graph. Is that part of this one? I think so. So this is the last part of this exercise. I'm just double checking because I made a mistake on the last one. The other way that you will identify a solution is by looking at a graph. Okay, now we said from earlier on that the way that you know it's a solution is when you find the point of intersection. Okay, so for this one here, this is probably the easiest out of the two questions. Find out of all the questions done, this one will be the easiest. Find the simultaneous solution for the graphs y equals minus x plus 4 and y equals 3x. Now, I've drawn those two lines here. Hopefully, this is a throwback to your linear relationship, so you recognize that y equals negative x plus 4 means it has a negative gradient, and it has a y-intercept of 4, which you can see with this blue line here. And then this one here is y equals 3x with no y-intercept, which means we cut at 0, and we have a positive gradient. To find the simultaneous solution, it's where these points intersect. And I've drawn this graph to scale, so I can say with confidence that this value here would be 1, and that value up there would be 3. Don't forget, x is always your horizontal, y is always your vertical. So in other words, the solution for this would be x equals to 1 and y equals to 3. Or I could write my solution would be 1, 3, because that's my xy coordinate. Okay, so either one of these two will be my correct answer. And if I was really suspicious, I would substitute in my answer into the equations just to double check. However, that is going to be correct. Okay, hopefully that makes sense, and I'll catch you guys in the next one. See you later. Bye.